Welcome everyone, I'm David Aboud. In today's webinar, we will discuss what's new in Altium 365 for April 2023. I'm excited to take you through the latest updates and enhancements to the Altium 365 platform. We've been working hard to improve the user experience and provide you with new and exciting features that will enhance your electronic product design process. Note that throughout the webinar, I will be initiating some poll questions, and at the end of the webinar, we will have a Q&A session. Please place any questions in the Q&A panel and not the chat area. As usual, a recording of the webinar will be sent out later this week. So let's dive in and see what's new. We're going to start off with a couple of new features dedicated to our Altium 365 web viewer. To start off, we have new default preferences, followed by multiple PCB and panel support within the web viewer itself. Lastly, we have the PCB compare functionality being added to our web viewer functionality. From there, we look at the project history export located inside Altium Designer. Additionally, we have ODB++ support added in the Altium 365 personal workspace. We also have the release of the MCAD CoDesigner 3.4.0, adding the ability to connect to new MCAD software like Siemens NX, and allowing us to move our rigid flex capabilities from beta to our public release. Our primary objective is maintaining the consistency in the project view between Altium Designer and Altium 365 Web Viewer. In the past, the default Altium Designer preferences used in the Altium 365 Web Viewer created discrepancies when non-default preferences were employed, leading to incorrect design displays during design reviews. Specifically, we have addressed the following issues. Number 1, net overscores not being displayed when a single negation is present within the net label. Strings appearing to be rotated, and custom net colors not being visible. To ensure that designs are displayed as intended, new preferences have been introduced in Altium 365 Web Viewer. The changes are as follows. Single negation on ensures that single net overscores are shown. Display strings are rotated off, ensures that strings always appear right side up. Net color override on, ensures that the custom net colors appear. With these new preferences, the design will appear in the web viewer exactly as you intended. It's important to note that to see the changes, you must recommit and re-release your project to regenerate the view with the updated preferences. Let's switch over and take a look at the preferences within the web viewer. Okay, first up, we switch over to the Altium 365 workspace and we have the Wi-Fi board controller. This design is part of the mini PC design that is included in our sample data. So the Wi-Fi board is an off-the-shelf board that you can connect directly through the mini PCIe port. But first, we're going to show the net color highlighting. See, here I have applied the net color highlighting to both the ground and the powered nets, as well as to my differential pair for my USB. You see that everything is highlighted appropriately, as well as the ability to see the single negation. If you want to create an overscore, you can simply add the negation line here, and it will become visible. Remember to enable the single negation preference in Altium Designer. Now, in the web viewer, additionally, we have this string. Originally, I placed this string at 180 degrees within the schematic itself, but as you can see, now it displays correctly here in the web viewer. This allows you to place, for example, a graphic or some text upside down for when you want to print out the schematic, but you are still able to see them correctly when you're in the web viewer. Next up, we have the beta release of the support for multiple PCB projects within the web viewer. This functionality allows you to view both embedded board arrays for board panelization and multi-board designs. This feature streamlines your design process, enabling you to access and collaborate on your entire PCB design in one central location. We are in the open beta phase for this feature and are eager to hear your feedback, so feel free to reach out. Remember, your insights and suggestions will help us refine and improve the functionality to ensure the best possible user experience. The ability to see multiple PCBs and panels from the web viewer makes it more accessible for design collaboration and review without requiring Altium Designer installation or licensing. The new features can be broken down into 5 sections. First, we have access to all PCB documents through the design tree in the Altium 365 project web viewer. Second, we have the ability to perform functions in 2D and 3D views, such as cross-probing, commenting, searching, net navigation, making measurements, accessing board information, and selecting variants. 3, we can view embedded board array objects for panel PCBs. 4, we have the option to measure panel PCBs between embedded board array objects or free point-to-point measurements between fiducial holes. We also have the ability to view multi-board schematics and multi-board assemblies. Once again, this functionality is in beta. You can see the individual schematics and the interconnections between the different device sheets. My favorite part is that you are also able to see the multi-board assembly. You can navigate through the individual boards and any of the enclosure files and toggle the visibility in order to get a better understanding of the design. Additionally, you can travel through the child projects as well as navigate through the design tree. We currently support visualization of the multi-board schematic and multi-board assembly. The bill of material visualization is currently in development. Over the years, we have added the ability to compare different file types within the Altium 365 web viewer. With our latest release, you are now able to perform the same type of compare functions with PCB documents. You can now run different PCB compare operations between different commits and releases of managed projects. This latest feature update complements the existing compare functionalities for schematic, BOM, and Gerber files, providing you with more comprehensive tools for reviewing and analyzing your design changes. Altium 365's compare capabilities are both versatile and designed for different purposes. Together, they facilitate design reviews and change tracking to help ensure design compliance. PCB Compare can be accessed easily via the Altium 365 Web Viewer Project History view or the Releases page, as well as the Altium Designer Project History view. Similar to the visualization provided from the other Compare functionality, we can detect changes such as board shape and board cutout changes, stack up changes, and net object modifications. This includes tracks, pads, vias, and even polygons. Non-net object modifications can also be detected with some exceptions, including graphics, 3D objects, and design views. Changes are presented in a clear and concise differences pane, allowing for easy navigation and cross-probing to the PCB compare view. In the PCB compare view, changes are color-coded and highlighted to give users a clear visual representation of the modifications. Red indicates removed items, green indicates added items, and yellow indicates modified items. Now we can switch over and take a quick look. Okay, so moving on to the PCB compare, we have the differences pane on the left-hand side. Here you are able to see, as I mentioned, red for removed, yellow for modified. If you click on the individual items, you will navigate through the design itself. And you can see the color coded to give you that simple visibility overall into the design. Notice that each individual section of a trace, for example, has that information brought in. Let's say we want to take a look at a particular net. We can come in here and go to the filter and go to the search area. I type in TP and it filters automatically based on that information. And we can once again navigate through everything just as we did earlier. Since these are test points, it's nice, easy to see everything in the design as we go through. When we come through the layers, we can toggle the visibility of the individual areas, toggling the top and bottom layer. You can see the top view and the bottom view as you can for all other types of files. You also have the filtered area, so if you have board shape, components, nets, stack up changes, you can filter it by that type of change here. As mentioned earlier, this completes the ability to visualize our changes throughout the design process with the schematic, the PCB, and the bill of materials, and lastly, our manufacturing files with the Gerber outputs. Altium Designer now offers the added capability to share project history reports with third-party entities in PDF format. This enables you to save them as release artifacts for backup and internal auditing purposes to ensure compliance. This feature has been highly requested from users in heavily regulated industries such as the medical, aerospace, and automotive industries. It can serve as a reliable confirmation of implemented changes that can be seamlessly integrated into quality assurance processes. Best of all, you no longer have to manually capture history page screenshots to achieve the desired functionality. You can simply save the project history report in a PDF to include general commit information, domain diff changes, and links to both commits and releases. This makes it easier for you to share your reports effectively, saving time and effort while ensuring compliance. Let's switch over to Altium Designer and make a quick report. Let's switch over to Altium Designer and make a quick report. Let's take a look at the project history for one of the designs included in our sample data. You're able to see here all of the changes that have been committed throughout the process. If you're unfamiliar with the project history, note that the addition of the PCB compare functionality closes out the full design process so you can analyze schematics, PCBs, bill of materials, and the Gerber outputs. Coming here, we can see the different types of design objects that have been added, removed, or modified. You can do a comparison between the different types of files as we saw with the PCB compare functionality. Moving over to Altium Designer, we have our outjob file for this project where we can define the type of project history report. Under Add New Report, we select Project History and then connect it to our PDF and select Generate Content. To save time, I have pre-generated a report which we will look at in a second. But you can also see if we come through here and go to the report section of an open document, we can build the project report. Start by selecting the Reports menu, Project Reports, and then Project History. We can customize the period of the report for the entire project history or between different releases. Switching over to the report itself, we now see the entire design history. We can easily see all of the differences between the revision releases and navigate to the detailed visualization of comparison between the file releases. Switching things up a bit, our next feature is located in the Altium 365 personal space. Continuing our efforts to increase the manufacturing data available on the personal space, we have added the ability to incorporate ODB++ files. Once you upload an ODB++ package to your personal space, you can switch between layers, take 2D measurements, share your designs, and add comments. As a registered user of Altium 365, your personal space is only accessible to you. You can access your personal space by logging into Altium 365 and navigating to My Personal Space. We simply need to click on our file package and we will open up the web viewer to view and visualize the design. Once in the viewer, we are able to change the layers, take measurements, share the design, and add comments. The ODB++ file visualization is very similar to the Gerber visualization that we have already implemented. You can also take your measurements and add your comments on the right-hand side. As always, you can share the design at the click of a button. Any changes that you apply to the layers will be updated in real time in the visualization. Let's go back one step, and let's say we want to add a new file. You simply go to New. You can see the support for the different file types for Eagle, KiCad, and Gerber. So we come through to the ODB++ and click, and in a couple of seconds, the files are uploaded. This is the same file that you just saw, but I wanted to show how quickly you can add it and get started using the viewer. The latest release of the MCAD CoDesigner version 3.4.0 is finally here. With the latest release, you can connect native ECAD and MCAD design components to Siemens NX. This allows both engineers to work simultaneously on their respective components, saving time and enhancing collaboration. Moreover, the new release includes advanced copper geometry support for Siemens NX, giving you even greater detail for your designs. You can now obtain precise definitions of shapes on every copper layer, ensuring accuracy and consistency, enabling simulation. Additionally, Release 3.4.0 provides MCAD data management system support for specifying MCAD components as ECAD footprint parameters. This feature streamlines your design workflow and better supports the relationships between components and footprints. In addition, we have moved the Rigid Flex design capabilities from open beta into the public release. This means you can simplify the workflow for Rigid Flex designs and completely eliminate the manual file transfers. Taking a look at the CoDesigner panel within the Siemens NX interface, we have the same push and pull that we are familiar with from the CoDesigner. In the top right corner, you can click on the user profile and navigate to the settings. Here we can enable the Build 3D Geometry button for the copper. Creating the advanced copper geometries allows us to use them within our mechanical tools for simulation, for example, for stress and thermal analysis. You are also able to enable the building of 3D copper for the vias. Note that the ability to create advanced 3D copper geometries is already available in our other MCAD integrations, and this release simply adds the capability to Siemens NX. Additionally, we have added the ability to have mechanically driven component placements. The component will be synchronized with the parameter that is defined within our options and within our workspace settings. Let's switch it up now and head over to Creo Parametric. I'm excited to announce that the Rigid Flex capabilities are now officially out of beta. You are able to bring in any rigid flex designs and fold and unfold them within the MCAD environment. Combining the rigid flex visualization with the advanced copper geometries allows us to gain a better understanding of our designs, especially in the context of mechanical enclosures. Just as a recap, you are also able to define enclosures as different parts of your assembly. This information will show up inside Altium Designer when you push and pull the design. I'm going to open it up to questions now, so please fill in your questions into the Q&A area and not the chat. Let's reserve the chat area for any follow-up questions I might have for a particular question. I'm going to initiate the final poll and just thank everyone for attending, for anyone that isn't going to stay for the Q&A session.